For AQA A-level physics, I'm going to do some videos for the electronics option. So I've nearly done all of the option topics now. Electronics. So the option topics, if you don't know, on paper three is 2 hours and it's about a third of the A-level, so it's very important. 80 marks. Lots of questions about practical work and practical techniques and data analysis, and then 35 marks on your optional topic, which is usually not something you choose, but something the teacher chooses, unless you're in a very, very big college where you might have an opportunity to be in a different class where they teach a different option topic. It would be a shame if they said, oh, we're going to make this a self-study topic, because there's potentially a good amount of practical work in here. And it would be nice to be taught by somebody who knew what they were talking about. Anyway, so the electronics, not too mathematical, not too much maths in it at all. Lots of electricity. When you did electricity, if you were comfortable with it, if you were happy with it, if you enjoyed it, then good topic for you to do. If you struggled with electricity, then maybe not so good. If you do A-level computing, or if you just did GCSE computing, computer science, lots of overlap with computing, as we'll see. For degrees, obviously, a good preparation for computing, for electrical engineering, for electronic engineering. And as I said, hopefully you'll get some practical work done. I did mechanical engineering. I didn't have a clue about what electrical or electronic engineering was. I wish I'd done it, because I did a bit of it in my degree and I found it really interesting. Okay. Think about, maybe if you're going to do engineering, there's a few places where in the first year all of the engineers do the same stuff, and then when you really know what electrical and electronic and production and mechanical engineering is, then you choose in your second year what type of engineering to do. I know that Newcastle do that. Anyway, waffling on there. This is what you will do. So discrete semiconductor devices on their own. There's a type of transistor called a MOSFET. You need to know quite a bit about that. Then a little bit about Zener diodes, photodiodes, Hall effect sensors. The operational amplifier, which is an integrated circuit. So there's lots of bits and pieces on one chip integrated together. And there's different ways that you can use an operational amplifier, as we'll see there, a comparator, inverting, non-inverting amplifier, etc., etc. Okay. Analog and digital signals, loads of stuff about sampling, what is sampling, pulse code modulation, maybe comes up a bit later on, LC resonance, a bit more AC theory. You do a little bit about AC in the core, you do more here. So LC resonance, something called the quality factor, digital signal processing. So logic gates, AND gates, OR gates, NOT gates, kind of on their own, like static, joined together, and then sequential logic is dealing with like a stream of bits, a stream of data. Astables, what they are, and a little bit about how they work. And then data communication systems, how data is transmitted, like, for example, AM and FM, a bit more about optical fibers as well. Very interesting. I've not taught this for about 30 years, and it was really, really interesting for me to come back to it. I enjoy this topic very much. Anyway, and that's electronics, if you're lucky to get to do that.